Hi, this is Miss Park, and topic of today's lesson is linear quadratic systems. So what is that? So I'm just going to write the words. So linear quadratic system. So linear we know is a line, quadratic we know is a parabola, and a system is a word that was used last year. So before I tell you what it was for, I'll just kind of remind you that linear, okay, so here's a line, quadratic, there's our parabola. What could system possibly mean? So here's your clue from last year is that last year you had a unit in grade 10 called linear systems. It was unit 1. And what was that? So with the linear system, you had a line and then another line. And using the equations of the two lines, you found the point where they intersect, and we called that the point of intersection. So the linear quadratic system is the same thing, except that you have a line and you have a parabola. So the question is, in how many places can a line and a parabola intersect? So if we were to draw this, right? So think about it. If I had a parabola here and I have a line, and how many places could the line cross this parabola? So I could draw a line that crosses this parabola in 2 places, one here and one here. So this would have 2 points of intersection. I could also draw a parabola that has the line nowhere near it. So it's not going to cross it at all. This one will have 0 points of intersection. There's one more situation, and that situation is if the parabola is over here and the line touches it at one point. So I'm just going to draw it like that. Okay, the line just touches it at one point. That point, not necessarily the vertex, it's just some point on the parabola. That would be 1 point of intersection. And that line is special. It has a name, and the name is a tangent. So a tangent line will touch the curve, will go along the curve, but touch it only 1 point. Okay, so there's 3 possibilities for those. And could the line ever cross the parabola in 3 places? No, it can't. So in solving a linear quadratic system, we are looking for the point of intersection of the line and the parabola. So suppose I give you 2 equations. So the first equation is, so I'm going to write here, so solve the linear system, or in other words, find the point or points, I'll put the S in brackets, the points of intersection. And I'll give you 2 equations. So the first one will be the parabola, so it'll be f of x equals 2x squared plus 3x minus 2. And the line, we'll call it g of x, which is, let's go 2x plus 4. Okay, and I'll give you a moment to think about last year, how did you solve the system when you had 2 equations? Right? And so what did you do last year? We had the equation of this one, we had the equation of this one. We want to know what's the point of intersection. So what did we do? So what we did last year is we took the 2 equations. Last year we didn't know about function notation, so we just used y's. So I'm just going to rewrite these with y's. And then what we said is this point of intersection sits on both lines. So this point of intersection is a point xy where the same x and the same y will satisfy the equations of both lines at the same time. So it's the same thing for us this year, except that the first equation is a parabola and not a line. We want to find the points x, y that make both equations true at the same time. So seeing that y equals this first equation over here, And at the same time, y equals the second equation over here, we can set the two right sides here of these equations to be equal because they both equal y. So now if I do that, I'm going to have a new equation that looks like this. Okay, and this is my equation setting them equal. I'm trying to find the points of intersection. To solve this equation, so this is to continue from our solving quadratic equations lesson, we're going to need to move everything to the left-hand side to get it into standard form, ax squared plus bx plus c equals 0. So when I do that, I'm going to get 2x squared plus x minus 6 equals 0. And what can I do with this equation? So this one is the one that I have to solve to get my points. I'm just going to go to the next page. So 2x squared minus x plus 6 equals 0. Right? Before we find the point or points, let's see, how can we be sure that there will be points of intersection? And if there are points of intersection, how do we know how many there are? So the points of intersection, the number of points of intersection will be the number of solutions to this quadratic equation. So let's see, how many solutions does this have? What tool do we have to figure out how many solutions an equation has without solving it? So the tool we have is called a discriminant. So discriminant is b squared minus 4ac. Let's see what the discriminant tells us about how many solutions this equation will have. So b squared is negative 1 squared minus 4 times 2 times 6. And that is going to be 1 minus 4 times 2 times 6 is 48. Hold on one second. I wrote the equation wrong. Okay, that's why it didn't work out. Okay, let me fix that. So this was a minus. And so that's negative 6. And now when we add these all up, we're going to get 49. So this is, or some number that's greater than 0. So if it's going to be greater than 0, we know there are 2 points of intersection. Okay, so let's solve this and figure it out. So this thing factors. So I'm just going to factor it. And I'll just use trial and error. So let's put a 2x here and an x here. We can put a 2 here and a 3 here and see if that works. If we multiply this out, I can put a negative here, so I get negative 4x, and a plus here, so I get plus 3x. Yeah, that works. Okay, that gives me the same as the line above. When I solve these two, I get x equals negative 3 over 2, or x equals 2. And so what is the meaning of these two solutions that I got? That means that wherever this parabola is and wherever the line is, I'm finding the x-intercept of, I'm finding the x coordinates of the points of intersection. So now I have 2 points of intersection. So the first one is going to be negative 3 over 2 something. And the second one is going to be negative 2 something. So to figure out the rest of the POIs, I need to sub the x into either equation 1 or equation 2. And so I'm going to choose equation 2, which was the equation of the line, just because it's easier. So y equals 2x plus 4 will become y equals 2 times negative 3 over 2 plus 4. Which becomes, this is the first part's negative 3 plus 4, which is 1. So then I have the point negative 3 over 2, 1. For the other one, x is negative 2, so I will have y equals 2 times negative 2 plus 4, and that is equal to 0. So my second point is negative 2, 0. And that's it. And that's how you find the points of intersection. So remember that sometimes you might be asked how many points of intersection and not to actually find them. So don't go to all this trouble if you don't actually need to find the points. You can just use the discriminant on the equation to figure out how many solutions there are. And that's how you'll know how many points. Okay, thank you for watching.